Hey students, this is the video feedback for the assessment from last Thursday. It's Chapter 5 Assessment 1. There's a retake ready to go, so you're going to watch this video, review, make sure you understand those concepts, practice, come to office hours, and then take that reassessment. Alright, so let's roll through this. This first question right here, what the main point is we're looking for is that you understand in context this number is the initial value, right? That's the initial value which represents their profits that they started with. Okay, so the idea is this is the profits that they started with, $150,000, 210. All right, what does the 0.82 mean then? Well, this means that it is decreasing, right? Their profits are decreasing over the next 12 months. And so how much are they decreasing by? I wanted to see you subtract 1 from by 0.82 and see that it is 0.18, which means that it is an 18% decrease. So to get full credit on this type of problem, you have to tell that means it is decreasing by 18% since it is 0.18 less than 1. Okay? On question 2, the daughter is starting with $15 and it's increasing 12%. Same idea. If it's increasing 12%, we add that to 1 and we get 1.12 to the x power. So it's 112% of the starting value, which is 15. That's the explicit form, and then the recursive form shows it starts at 15, right, and then it's multiplied by 1.12. So these are the two answers you should have for this situation. Remember, the left side is the explicit function, the right side is the recursive model. All right? Taking a look at this pattern then, all right, our a of 0 is our starting term here, and so that's 2. And hopefully you see that you're multiplying by 3 each time to go from 2 to 6 to 12, or sorry, to 18. You're multiplying by 3. And so to find that, right, we take our initial value, ace of n, right, and we multiply each function or each previous term by 3. So how would that look in our model? 2 times, in our explicit function, times 3 to the x power, right? That's recursive into explicit, all right? Here we have a recursive form. Since we are subtracting 3 from each one, we should say, oh, this is a linear situation. Our explicit function should be linear. And so our first term here, it says is 4. It's subtracting by 3 each time, so we go down this way. But again, we need to know our initial value, our y-intercept, in order to do this. So we go backwards, and we see that our y-intercept is 7. And so our explicit linear function is negative 3x starting at 7. And again, I'm not seeing many of you test your equations to then see if you're correct. All right, this is our initial value is 15, and it says we're going to multiply by 3 each previous term. So 15 times 3 and 45 times 3. Again, you don't need to know what n of 2 and n of 3 are, but you do need to know what n of 0 is. So if you see the pattern multiplying by 3, all you need to do is go backwards in that pattern and see that our initial value is 5. Writing our explicit function for an exponential, its initial value times that growth factor, 3, to the x power. And so that's going from recursive to explicit, and that's the skill I'm testing there. Now, read through this question. John's saying, hey, look, I have this linear function into a recursive function. If the initial term a of 0 is 5, which is correct, a of 0 does equal 5, then you just multiply by 3 to find the next term. Well, if you're wondering, does that work? Do it in your head. 5 times 3 would be 15, times 3 would be 45, times 3 would be 9135. Does that look like a linear function to you? No, he did it wrong. You don't multiply by 3. What do? You take the previous term and you add it to 3, right? A linear function, we don't go up by multiplying. We add, what am I doing? 3. And so that should be how his recursive function should be defined. All right, so explain that mistake. We only had a couple people get that, so that was a tough question. All right, so now this one, I think I have 2 people really explain this well. And so this idea is we have an option that's multiplying by, or increasing by 10.5% each year, and an account that grows by 20% each year. You should know one of these is linear and one of them is exponential. If we go up just by $20 each year, right, that is a linear function. But if we go up by multiplying by a percentage each year, that is an exponential function. So let's grab the graph that represents this. And I just want to show you, these are the 2 functions you should have been able to find. And let's see if I can move this over a little bit so you can see it. Right, this first function should be the $100 that they're starting with, and it's multiplying by 1.105, right? It's increasing by 0.105, 10.5%. And that's this red graph right here, okay? Then the second function, starting point is 100, but it's only going up by $20 each time. It's this linear function. And you can see it's this blue line right here. And you can see our starting point is 100 for both of them. Right here, boom. Let me make sure that's there. 100 right there. And the linear function is going up at a steady rate. The exponential function then is growing quicker and quicker. And you can see pretty quickly the exponential function is going to be bigger. All right. Only going up by $20 does not improve very much. But now where do we find that value? And that's this vertical line, x equals 18. And so you're going to have to zoom out or just go where they intersect to find these values. And I have both of these values labeled here. For the blue, our linear function, it's 18 years gives us $460. And our exponential function, 18 years gives us $603. So the difference is $143.28 in option 1. And so the correct option should be option 1, right? Because that it grows by 10% each year, and eventually it is bigger than our initial value. If you just did a couple values like I saw some of us did, you would think that, yeah, going up by $20 is a better idea. And you can zoom in and see that for a little while, see the blue function is better. And then eventually the red function, our exponential, crosses and changes. Let's keep going. There it goes. It's going, and boom. So you can even see at year 12.61 is when they're equal. And then from then on, our exponential function is bigger. All right, hopefully that gives you the strength you need to study this and understand it. Come to office hours and we can walk through any of these questions. But it's on you to practice this and prepare for your retake. All right, thanks for watching. Log into your Desmos and walk through your questions. Have a great day.